different designs were introduced in Indian Railway. There are certain factors which affect the comfort level of the passengers when they travel in a train. And these comfort levels are primarily divided into temperature, humidity, velocity of air, purity of air, and noise. These are the 5 different factors which decide comfort level of a passenger. And all these factors which I have mentioned, they are related to electrical equipment which are meant to provide air conditioning in the AC coach. There are other different parameters which also decide the comfort level, but they are not connected to the electrical equipment. Therefore, I have mentioned only the ones which are relevant for today's topic. There are 2 important criteria or factor which decide the comfort level for the passenger. The first one is the humidity, and to be precise, relative humidity. And the second one is the temperature. If we have the right combination of relative humidity and the temperature in an AC coach, the passengers will feel comfortable. Any mismatch or any unbalance in these 2 factors will cause a lot of complaints from the passengers. To make the concept more clear, I have mentioned the basic definitions of absolute humidity and the basic definition of relative humidity. The absolute humidity is the mass of water vapor, which if we divide it by the mass of dry air, then we get the absolute humidity at a given temperature. The absolute humidity, it is expressed as gram per meter cube. And hotter the air is, the more water it contains. So this is the first principle when we design the air-conditioned environment. When the air is hot, the amount of water vapor which is already present in the air is less. And therefore, we can add more water to it. We can saturate it further. So in case the outside temperature is high, we can presume that the water content is less in the air. The factor which is important for air conditioning is relative humidity. It is nothing but a ratio. It's a unitless ratio, which is the ratio of current absolute humidity to the highest possible humidity, absolute humidity which is possible in the environment. And definitely it depends on the current air temperature. The 100% relative humidity means that air is totally saturated with water vapor and no more water can be accommodated in the air. When we arrive to such a situation, the relative humidity becomes 100%. Why the relative humidity is important for AC coach? So I'm trying to explain using 2 examples. If the relative humidity is low, we feel much cooler than the actual temperature because our sweat evaporates easily, cooling us off. So this is the basic phenomena which takes place. And this is one of the examples. Suppose the air temperature is 24 degrees Celsius and the relative humidity is 0%. Then the air temperature please mute your mic. Mr. Champak Jyoti, please mute your mic. Thank you. So, where were we here? So, if the air temperature is say 24 degrees Celsius and relative humidity is 0%, then our body feels as if the air temperature is 21 degrees centigrade. On the other side, if the air temperature is same at 24 degrees centigrade and the relative humidity is 100%, then we feel like as if the temperature in the environment is 27 degrees centigrade. So just by manipulating the relative humidity in a coach, we can change the perception of the passengers who are traveling with us. There are 2 ways of controlling it. We control the relative humidity and we also control the temperature, and we try to make a balance between these 2 vital parameters to provide comfortable environment in a coach. Now this is the overall system, how the relative humidity is controlled by any air conditioning system It may be a stationary air conditioning system, or it may be a air conditioning system that we have in a moving plane. Suppose the outside ambient air is 37 degrees centigrade with 95% relative humidity. If suppose that is the condition in which an AC coach is supposed to travel, we send this air over an evaporator at 4 degrees centigrade. When we reduce the temperature from 37 degrees centigrade to 4 degrees centigrade, the capacity to hold water gets reduced. As we know, as I have already told that hotter the air, more water can be accommodated in the air. The moment I reduce the temperature, the capacity to hold water also gets reduced. And the excess water, it comes out of the air in the form of moisture, and that moisture can be removed from the entire system. Once I have removed the overall water contained from the air, we again raise the temperature. When we raise the temperature, then the relative humidity, it again becomes higher, and now it has the overall air, it has the less moisture as compared to what it had when the temperature was 37 degrees centigrade. So this is a hypothetical example that from 37 degrees centigrade with 95% relative humidity, I have brought it to 21 degrees centigrade with 50% relative humidity. This cycle we keep on repeating to ensure that the relative humidity remains under control. As per the design which has been issued by RDSO, the maximum permissible relative humidity in an AC coach is 60%. It cannot go beyond 60% because most of the human beings, they feel uncomfortable if the moisture level or if the relative humidity goes beyond 60%. The unit of refrigeration, all of us know about it, so I will quickly go through it. The 1 ton of refrigeration is equivalent to 3000 kilocalorie per hour, and roughly we need, whenever we want to calculate the capacity of a system, we calculate, this is the empirical formula, that 1 ton will be required to cool, to keep an environment, an area of 10 by 10 by 10 cubic feet in the comfort level. So whenever the electrical power people, they design a system, they use this formula to decide the amount of the total tonnage which is required for the AC equipments. When we started the air conditioning in AC coaches, we started Freon 12. When the production of Freon 12 stopped because of the environmental concerns, we moved on to Freon 22. Later on, Freon 22 was also banned. It was banned to sell Freon 22 in open market, and the supply to railways was also stopped. So we moved on from Freon 22 to R134A, which is halogen-free gas, and it does not affect the ozone layer. This is environmentally friendly refrigerant gas, which is now being used in the AC coaches all over India. These are the 3 major components which are provided in an AC system in a coach. The first one is the compressor, which compresses and delivers the gas into condenser at a high pressure and temperature. I will try to explain them again in the next slide. When we see the refrigeration cycle, the condenser is the component which cools the hot gas and liquefies it under pressure. An evaporator is a unit in which liquid freon under low pressure, it evaporates, and when it evaporates, it takes away the latent heat which is available in the air, thereby cooling the medium surrounding the cooling coil. So the system principle, the principle of air conditioning, which I explained earlier, it is being performed by 3 different components which are provided in an AC coach. This is the entire refrigeration cycle that we see in the coach. Another important component which is also there in the AC coach is expansion valve. The expansion valve, it controls and regulates the rate of flow of liquid freon under high pressure. depending upon the requirement of switching on and switching off the AC plant, and depending upon the variation in the temperature that we have to maintain, the amount of refrigerant is controlled by the suspension valve, and only appropriate amount of refrigerant it is allowed to pass or circulate in the system. Here, the evaporator, the bottom line, it is the low pressure vapor line, and the red line is the high pressure vapor line, where the entire refrigerant is in the liquid form. This is the cycle, it keeps on repeating. And the warm air, when it comes in the contact with the evaporator, it becomes cool. And in that process, the entire air conditioned air, we pass it again to the coach using the vents. We have the vents and the entire system which is available in the coach from end to end. And conditioned air, then it is passed to travel in the coach. Here are different systems by which the refrigeration cycle can be, designed and can be used. In the advanced refrigeration systems, there is a circular 100% fresh air is being taken into each cycle. The air conditioned air, it is thrown away into the environment, and fresh intake is being taken, and 100% fresh intake is taken, and the fresh air is then circulated again in the system. In order to achieve that kind of a system, the capacity of the compressors and the entire system should be very good. And here in Indian Railway, we, as per design, we allow only 20 to 30% of fresh air intake in every refrigeration cycle, in every cycle. The balance air, which is already air conditioned, it gets recirculated. We have done it because we've observed, or the RDSO established, that mixing of air conditioned air with the 20 to 30% of fresh air is adequate enough to meet the standards for the air conditioned environment to be provided in the coach. And secondly, we have the restriction on the amount of space which is available in the coach. If I want to intake 100% fresh air, my overall system will become bulky. I will need more space in the coach. And at the same time, the power requirement will also go high. We have limited generation of power. Earlier, the limitation was because of the self-generating coaches. Now also, although now spare capacity is available in the form of spare DG sets which are there in the power car, but we have not changed the design. And in principle, whenever a vendor or a supplier wants to provide his equipment for the coaches, we ask him to certify or get it verified that the system will work if we allow only 20 to 30% of fresh air mixing with the air conditioned mixing, with the already air conditioned air. So different functions are performed by different components. We have 4 such circuits in an AC coach. The 2 circuits are on one side of the coach, the other 2 circuits are on the other side of the coach, and all these 4 circuits, they can work independently. During the normal course of working, only 3 out of 4 are kept in service. 1 is kept as a standby. Even by allowing the 3 systems or 3 circuits to remain working, the air conditioned environment can be created in the coach. So that is how the redundancy has been built into the air conditioned coach on Indian Railway. There were many issues when we started the air conditioning, and the number of failures were also high. The first and the foremost requirement is very high reliability standards. When the passengers are traveling, we have no other source of uh, air conditioning the coach if there is a failure in the air conditioning plants. And since the AC coaches, they are packed, we don't allow the outside air to flow into the coach. In case the air conditioners are not working, it will be unbearable for the passengers. So reliability is very important. The AC plants, they are supposed to perform, they are supposed to remain in working condition throughout the journey. The journey may be more than a 1 day's journey. There are long distance trains which run for more than 36 to 38 hours to reach the destinations. So it is important that the reliability is very good. Secondly, the equipment should be light in weight because any additional weight is going to add to the tear weight of the coach. The equipment should take minimum space because in case I want to have more space for air conditioned equipment, I shall have to compromise on the space which is available for the passengers. Therefore, we have to design the equipment optimally considering the overall efficiency of the system so that we can fit into all the equipments into the bare minimum space which is available in a coach. The available power which is being generated by the DG set or being generated by the self-generating coach, it has to be utilized. So the air conditioned equipment should be designed in such a manner that they should not require for any other type of voltage or any other type of current requirement. The fourth important criteria, which is also considered as a design criteria, is that we have no control on the passengers regarding their movement in and out of the coach during the entire journey. There are many people who keep moving in and out of the coach, and there are many people who stand at the door even after opening the door so that they can talk to the people and they can also enjoy the cool air which is there in the coach. All such movement in and out of the coach, they amount to excess leakage of the air conditioned air. And whenever there is a leakage in air conditioned air, the temperature becomes high and the load on my air conditioned equipment it also becomes very high. So therefore, whenever we design a system for air conditioned coach, a certain percentage of leakage in the air it is also taken into account because of the continuous movement of people in and out of the coach. The rapidly changing ambient condition also make the working of air conditioners difficult. During the winter season, we have extreme cold conditions in the north, where the temperature can be 0 degree or below 0 degrees centigrade, with the relative humidity very near to 100%. Where the moment the train moves from northern part of the country to southern part of the country, where the weather conditions are very good, we have to switch on the which we have to move the air conditioned plant into the cooling mode. Whereas during the same journey, when the train was moving in the northern part of the country, we had to switch on the heating arrangement of the uh, AC plant. So the changing ambient country conditions as per the geography and the territory in which the train is moving, the requirement of conditioning the air keeps on changing. So the plant should be able to take care of it without manual intervention. The excessive vibrations are another issue which is creating problem. Initially when the air conditions were designed, they were designed for the stationary equipment because the components and the equipments which are there in an air conditioned equipment, they are connected using the copper tubes which are braced to each other. The vibration makes the life complicated for these copper tubes and the joints and the bracing joints because the vibration may cause cracks getting developed in the pipeline. As a result, the refrigerant gas may escape into the air and the AC plant may stop working. The dusty atmosphere impair the exchange of heat from the AC plant to the environment. And if the overall all the equipments are dusty, the exchange of heat will be low and the efficiency of the AC plant will also be low. The safety of passenger is also important because the AC equipments they work at 400 volt. And the rules and regulation of Indian Electricity Act, they are also applicable on air conditioned coach. We have to design the system in such a manner that people don't come in contact with the live wires, they don't they don't get electrical shocks. And we also have to make the arrangement that the air conditioned equipment should not catch fire during run. So all safety related norms which are supposed to be maintained are maintained by the maintenance staff during the maintenance of coaches in coaching depot. So these are some of the important issues which we face when we design the air conditioned equipment for the coach and when we maintain the coaches in the coaching depots. These are the design parameters. These design parameters I have picked up from the RDSO manual. The supply clean, fresh air at a controlled, unified temperature, uniform temperature. We have to cater to the continuously changing number of passengers. There is a possibility that only 2 or 5 people are traveling in a coach, and there is a possibility that the coach is overcrowded, and it happens when during the festival season and during the summer break, and the more than the permissible number of passengers, along with heavy baggage and luggage, they travel in AC coaches. So the air conditioned plant should be designed in such a manner to take care of these extreme situations also, and the heating and cooling, and this is all I have already explained. These are the different temperature settings which we have provided in the coach. Earlier there were 3 different settings, and we could change as per the requirement or as per the request of the passengers who are traveling in the coach. The entertaining the request of the passengers was creating a lot of problem for the staff, and when the technology improved and we found that these are the most comfortable range for the passengers, we decided to do away with the 3 ranges, and when we started going ahead with the single range of uh, temperature settings in the AC coach. During the summer, the temperature is set between 23 to 25 degrees, and for winter, it is between 19 to 21 degrees centigrade. We have cut in and cut out kind of an arrangement which takes care of the temperatures within these range which have been specified. The temperature settings, they are also displayed in AC coach to keep the passengers informed about the temperature settings and to reduce the passenger complaint. This was not done earlier. We were not very open about the temperature which was provided in the coach, and passengers used to complain that the cooling is not adequate or the heating is not adequate, and a lot of unpleasant situations have been created in past because of the hot discussions that took place between the AC coach attendant and the passengers. In order to avoid passenger complaints and to make things more transparent, we have started providing these stickers on both side of the coaches on the AC coach panel itself, so that the passengers are now aware that what they should expect, and in case there is any requirement which is beyond these range, then it is not possible to entertain their request. So number of complaints have reduced, although we still encounter some of the passengers who still complain that these temperature ranges are not comfortable to them. There are passengers who still insist that during the summer period, the temperature should be kept as low as 19 degrees centigrade. We receive all kind of requests, and it is not possible to entertain them because we have to maintain a temperature which is comfortable to most of the passengers who are traveling. And these are that after doing some study, these settings have been worked out. Depending upon the number of passengers who are traveling in the AC coach, the requirement of AC load is calculated, and according to the requirement of the AC load, the capacity of AC plants is also decided. So we do the calculation first, arrive at the total AC load, considering change in weather, considering leakage of the air conditioned air, and or other parameters, and we arrive at the optimal number or optimal requirement for AC load of the coach, assuming that the entire coach is full. So we design it considering that each and every seat is occupied in the AC coach. In AC first class, the requirement is 5.3 ton, and we have provided only one plant which has a capacity of 6.7 ton. In AC2 tier, the requirement is 7.48 ton, and we have provided two plants, and each plant has a capacity of 5.2 ton. So, in case if you see that In case even if one of the plant is not working, then I am left with the capacity of 5.2 ton. And with the 5.2 ton, we have to take care of the AC load requirement of 7.48 ton. There are situations when the one of the AC plant is not in working condition. In that case, the 75% of the we meet these half of the capacity is not there, and the entire coach is being attempted to keep in air conditioned environment by using a single plant. Then under these circumstances, the AC coach attendant, he becomes very careful. He tries to control the movement of the passengers, and remains alert that the excess passengers should not travel in the coach. He takes certain written and unwritten measures to ensure that there is no passenger complaint and the coach can work up to the destination. There is a question from Chirag. Is there any standard taken star rating in air conditioning for air AC coaches? No. Star rating is not there in the air conditioning coach plants for the AC coaches. What about air conditioning in Palace on Wheel type premium trains? Yes. In Palace on Wheel types of premium trains, we are using a different system. We have in some of the coaches which we are using the standard split type of air conditioners also. And in some of the trains, we are using the same system that we have in the AC coaches. Is it similar to regular AC coach? Yes, it is similar to the regular AC coach. And the Palace on Wheel train, it is being maintained by Ajmer Workshop. The Maharaja train, which is being operated by IRDC, ITDC, it is being maintained by the Ajmer Workshop. Ajmer Workshop is the nodal agency for maintaining the AC plant for Palace on Wheels. I have done the maintenance on Palace on Wheels for 2 years when I was posted as a Deputy CWE Ajmer Workshop during the year 2004 to 2006. The AC composite coach has 2 plants of 5.4 ton capacity, and the other, when you have talked about the Palace on Wheel, let me also share one more information. In the Palace on Wheel, there is no railway employee who accompanies the train. The Palace on Wheel, it is managed by the Rajasthan Tourism Department. Even the tickets are being issued by them. They only do the ticket checking in case it is required, although it's a premium train. I think as on date, as per the prevailing rate, the per passenger ticket for one night is somewhere around 1 lakh rupees per person. So that is the rate for the ticket per person per night. And they also take care of all the hospitality and everything. They only allow one supervisor to accompany the train, and with the strict instructions that the supervisor or the staff cannot move in the coaches on at his own will. Only if he's allowed to move in an AC coach, he comes in the AC coach to see the working of the AC. Otherwise, he remains at the designated place in the train itself. The AC composite coach, it has as the number of passengers are more, the requirement is more, and the capacity of the plant is also high. And then we have the highest requirement in AC 3 tier, and accordingly the capacity of the plant is also high. So these are different requirement of AC coaches and their capacities in the AC coach. There are two systems for the generation of AC air conditioned requirement into the coach. The first one is the self-generating AC coach, and the other one is the EOG AC coach. So we have two different modes of generation of electricity for a smooth operation of AC plant in a AC coach. In the self-generating air conditioned coach is similar to what we have seen in the train lighting coach. The only difference is that the Ratings of the equipments is different. The size of the equipments are different. The power which is required in self-generating AC coach, it is being driven, it is being provided by 25 kilowatt alternator, which is linked or connected through the axle pulley. And at low speed and halts, the power requirement is being met using 110 volt lead acid battery, which is mounted in the underframe of the coach. So these are the two arrangements through which we provide the electricity requirement to the AC plant. The other one is the EOG kind of an arrangement. I explained a little bit about DG sets and the power cars when we took session on the tail lighting equipment. The output supply is at 750 volt three phase, which comes out from the power car. And this power supply, it is being given or being fed to the coach using one of the feeders. The AC equipments, they operate at 415 volt three phase. So we have to provide a 150 kVA transformer in each coach to step down the voltage from 750 volt to 415 volt. Then the lights and fans, they operate at different voltage. Lights and fans, they operate at 110 volt single phase. So I need another transformer. The capacity of the transformer is 3 kVA. And we do the second stage stepping down of the voltage, in which we step down the voltage from 415 volt to 190 volt three phase, and we connect the equipment or the lamps and the fans in between one of the line and the neutral, so as to achieve 110 volt AC supply, which is required for lights and fans. So there are two levels of stepping down of the voltage, which is being made available from the power car. We have another provision, which is only for lighting the emergency lights. We have one battery which is provided in the coach, and it is connected to few numbers of emergency lights, and it becomes operational only during the emergency. And the emergency can be mostly it comes when the coach gets derailed. Suppose one of the coach is derailed, and if it's an EOG kind of an arrangement, the entire couplers, they get disconnected. So we have no source of supply for the air conditioned equipment and the train lighting equipment for the coach. The other option can be, now the coach is derailed, it is stationary, in a stationary condition. So if it's in self-generation kind of a coach, there is no generation from the alternator because wheel is not moving. And if even the battery gets disconnected from the circuit, so the battery backup is also not there to have the regular supply for the leave alone the plant. We don't have the regular power supply for the train light and the fans. During such situation, the battery takes over. It has a sufficient capacity. The capacity is 24 volt, 19 ampere hour, and then this battery is being used to provide emergency lights so that the coach does not become dark, and it remains active till the rescue operation starts. So this is the only function for which battery is provided to provide emergency lights in the coaches. There is a requirement as per the guidelines that Gautam, please mute your mic. Okay. There is a requirement that before we allow the passengers to board the train, the AC coach should be air conditioned. Now, I have 2 or 3 different methods of air condition the coach. The first one is that I can use the stored energy which is there in the form of battery if it's a self-generating coach. It is the worst kind of an idea to consume the stored battery which is available, stored energy in the battery, because that stored energy is to take care of the emergencies or to take care of the power requirement during halt. So if I consume that energy, there may be a problem during the run. So as per the rule, the coach is never pre-cooled using the stored energy in the battery. The other option is if I have the EOG kind of a coach. If I have an EOG kind of a coach, I can start the DG set and I can get the power supply extended to the coaches so that the AC plant can be air cooled. We don't start DG sets much before the departure of the train because of the noise pollution and because of the smoke pollution which is there at the platform. And it is not appreciated by National Green Tribunal, and it is also not being it has not been appreciated by the passengers also. So we sometimes we have no choice but to use the power cars to pre-cool the coach. But rather than using the DG set, because when I use the DG set, I am actually consuming high-speed diesel, which I would not like to do it. So we have another arrangement to pre-cool the coach, and we have a 200 capacity battery charger which is provided in the coach. And the battery charger, it takes 440 volt three-phase power supply through the special battery charging sockets which are mounted diagonally on each wall. We have two battery charging terminals which are mounted on diagonally on the opposite side of the wall, so that even if depending upon the direction of the coach or the orientation of the coach, I will have at least one battery charger which is available to me on the other side of the coach, on the other side of the platform. So normally we have the platform, then we have a coach in between, and the entire charging arrangement, it is provided on the other side of the coach. Because when I want to charge the coach, I have to connect the coach with the leads, with the power cables. And if I spread the power cables on the platform, it will become inconvenience to passengers. So we have decided to keep the entire charging arrangement between the two tracks. If I have platform number one, then line number one, then line number two, and then platform number two. Normally, that is how we have designed our railway stations. So the charging arrangement and the watering arrangement, both the arrangements, they are provided between track number one and track number two. Both these arrangements, they run parallel to each other, but taking due care of insulation level which is required for the charging system, and to avoid any ingress of water because of the water charging arrangement which is also there. So this is how we charge the transformer, or we cool the coach. In case normally 20 to 30 minutes of pre-cooling is sufficient to get the required temperature which is required for the passengers. There are certain drawbacks that we have faced in the conventional system. Some of the drawbacks are similar to the drawbacks that we saw in the self-generating train lighting system. In this photograph, you can see that the AC equipments, they have consumed the entire space, and all the tubing, copper tubing, that is also situated in the undergear of the coach, and they are also exposed to the environment because it's a open kind of the refrigeration system that we have used earlier. There is a possibility that the external body or some ballast, some external equipment or external foreign body, it may touch or it may hit the refrigerant gas system, and it may develop the cracks, and there may be a leakage of the refrigerant gas. Second disadvantage was the high weight of the AC equipments, and it contributed to the overall coach tear weight. Then large space occupation that you can see. This is one photograph of one plant. Then we have similar position. So entire space is occupied by AC plant. There is a maintenance problem for the underslung equipments. Suppose the rake is placed at the platform, and the staff who is accompanying the rake, if he finds that there is a small problem which is affecting the overall efficiency of the coach, and it can be attended. Even if he wants to attend that small problem or trouble, he cannot do it because he cannot access the air conditioning plant by going down under the coach. There is no space for him to go under the coach. It is highly unsafe to allow the staff to do work under such risky environment. And thirdly, he can neither sit under the coach nor stand under the coach, so he practically he cannot do any work. So sometimes even if the trouble is identified and if it is manageable before the departure of the train, we allow it the coach in the similar condition along with that small trouble, and we leave it unattended. This kind of a problem is not there now in the modern design that I will discuss later on. Energy efficiency is low because the overall environment is dusty, the heat exchange is poor, and the efficiency, the components or the equipments which were provided earlier, they were also not energy efficient. So overall energy efficiency of the system, it was low. So these are the some of the disadvantages that we had in the conventional AC coach. In case I ask a question in the exam that what are the advantages of RMQ coach or what are the disadvantages of conventional AC coach, your answer will be on the similar lines. You have to write on the similar line. In case I ask for the refrigeration cycle, then you should be in a position to draw the refrigeration cycle. In case I ask you to mention the function of the components of the refrigeration cycle, then you only have to write the name of the equipment and its function. You need not draw the refrigeration cycle. So read the questions carefully and accordingly you answer the question, whatever the question that is going to come for you in the exam that we are going to have on next Friday. Did I explain the overall structure of the question paper to this group? Can somebody say?
No, sir.
No. Okay. I think I have explained it to the earlier group. The total, the exam will be for 35 minutes as usual for the other subjects. Then, then there will be questions of 20 marks, which will be of in the objective question marks will be there for 20 marks, for approximately 20 marks. There will be multiple choice questions, yes, no type of question, and fill in the blanks. There will be few fill in the blanks type of questions, which will be there. Then in the descriptive part, I will ask you to attempt either 5 out of 7 or 5 out of 8 questions or 4 out of 7 questions, depending upon the length of the answer that you are expected to write. So there you will have to attempt, most probably you will have to attempt either 4 or 5 questions. And you will have a choice to select and then attempt the questions. So you read the question paper, select the questions which you feel can fetch more marks to you, and you attempt those questions. There will be no shortage of time, that I can assure you. The third important issue which I want to discuss with the group, that in case there are more than one part in a question, suppose question 1 has part A and part B, and question 2 also has part A and part B, you have to attempt part A and part B of one question only. If you attempt one part of question number 1 and one part of question number 2, I will not consider as one question. I hope I have made it clear. In the past, some of the probationary officers, they had to sit for the supplementary examination because they did not follow the basic rule. They attempted all 7 questions, and because they felt that part A of one question and part B of another question, it will fetch them marks. And if they have attempted part 1 and part 2 of the different questions, it will be considered one question. Does not happen like that. You have to attempt question out of 7 questions. You have to attempt only 4 questions. You cannot attempt all 7 questions and expect the faculty to evaluate them. So I could not give them the marks for the extra questions which they attempted, although the answers were right. But I could evaluate only the first questions, and I left the rest of the questions unchecked for them, and they could not pass the exam. Although they knew the subject very well, they attempted all the good questions, and they could have scored 100% marks. But because they did not follow the basic principle of attempting the question paper, they had to appear in the examination. I felt very sorry for them. I showed the answer sheet to them. I explained to them that this is the mistake which you have done. blindly appear in the supplementary examination. And it was painful for me to take their supplementary because they were some of the bright probationers, and it was the overall scene got affected. So here again, I am requesting all the groups that please don't commit this mistake. If you are attempting a question, attempt it fully. If you attempt part one of question one, part two of question, part one of question two, part one of question three, and part four of question four, I will not count it as attempting two questions. I will count it as attempt that you have attempted four questions. I hope it is clear. If it is not clear, let me say, I will repeat it again. But there are certain officers who don't take care of this particular problem, and more than half of the number of officers who appear in supplementary for my examination, they appear only because of this reason. And I think this is something. This is a very simple reason which can easily be avoided by all of us. So make sure that you read question paper properly. There will be choice will be given to you. Spend 2 to 3 minutes before you start attempting the question paper. We have moved from the let's come back to the subject. We have moved from the underslung AC coach to RMPU type of the AC coach. It was designed in 1992 especially for the rolling stock purpose, and it is mounted above the toilet on both ends of the coach. It can work on EOG and ST, and we are using reliable static inverters for conversion of 110 volt DC into three-phase AC. We use three-phase brushless compact motor. It is less bulky as compared to conventional AC coach. Initially, when we introduced the RMPU, it was 5.2 ton capacity which was used, and it was considered inadequate for the AC2 tier system, because when we designed these RMPU units, we somehow undercalculated the leakage of air which can take place due to movement of the passenger. That was a parameter which was not taken into account properly, because it was not anticipated that the movement can be as high as possible. So therefore, there were some complaints in the coaches, and it was considered not adequate. So we revised the specification, and later on the capacity was enhanced. Now these are the different capacities which are now being made available in the AC coaches. This is how the RMP unit look like. We have the condenser fan and the condenser motors. Then the sealed compressor. Each plant has two sealed compressor. As I said, each sealed compressor is independent of working. We have the thermostat, which is provided in the return air path, and we also have the heating element. So these are some of the photographs which show you the inside of the RMPU unit. This is a requirement as per the specifications. In the first AC coach, the requirement is that we should have the fresh air inside the coach at the rate of 0.7 meter cube per minute per passenger. The another requirement is that here we should have two independent circuits. Each independent circuit should be able to work independently. So we have two compressors, two condenser, and two cooling coil cum heaters. Each RMPU should be able to work with one condenser fan and cooling capacity so as to obtain not less than 75% of the rated capacity. So this is the requirement, and the designs are approved only after these parameters and other parameters are met by the manufacturer of RMPU unit. This is a comparison just for the quick glance. You can see the weight is much less as compared to conventional AC. The amount of refrigerant which has to be charged is also less. I need only 3 kg refrigerant gas as compared to 15 kg in the conventional AC. The downtime for repair is also less. We have to simply remove the entire RMPU unit and we replace it by providing the new RMPU unit. Whereas in case something is wrong in the conventional AC equipment, I have to remove only one component. We remove one, we unbrace the copper tubing, remove the equipment, provide the equipment and rebrace the pipeline, and then carry out the test to check whether there is any leakage in the system or not. That test also itself takes more than 4 hours because we charge it at a particular pressure, and after a certain period of time, we check what is the pressure in the pipeline. So repairing the conventional AC system is much more complicated as compared to RMPU, which is a enclosed kind of a system. It is a plug-in, plug-out kind of a system. In case there is any problem in RMPU unit, we simply straightway remove the entire RMPU unit using the crane and replace it with a healthy equipment. And then later on, we carry out the repair work on the RMPU, which is available now on the shop floor. The battery capacities are also different depending upon the type of the coach and depending upon the requirement of the coach. AC 2-tier, 3-tier, and composite, they have 800 ampere battery, and AC first class, it has one set of 525 ampere hour. This is how the coaching depot looks like. Then this is the end of this part. Now we will move on to the loco. I will explain some of the portion which is related to maintenance of electric locomotive. We will cover some slides today, and the balance leftover slides we will take in the subsequent classes. Today I will also share the PPT for AC portion. So far I have shared 2 PPT in the Google Drive, and today I have covered the AC portion for all the 3 groups. So by today evening or by tomorrow morning, I will share the 3rd PPT also in the group. There will be approximately 6 to 7 PPTs that I'm going to share as and when I complete the sessions in all the 3 groups. Can you see the next presentation, please?
Yes, sir.
Yes. Okay. So let us start the 3rd topic, that is the traction rolling stock. We begin the subject with the introduction of electric traction in India. It was introduced in 1925 when the first electric train it operated in Mumbai area from Victoria Terminus to Kurla. This was the loco which was used to haul the first train. It was EF1 class of locomotive, which was manufactured by a Swiss company, and it is now at display at Chhatrapati Shivaji Terminus, Mumbai. If you happen to visit Chhatrapati Shivaji Terminus, you can have a look at it. It's a part of it is now part of the history. When we introduced AC traction, when we introduced electric traction in India, we started with the 1500 volt DC system because that was the only technology which was available for us to adopt. We did not invent the or design the electric traction. We have copied the electric traction systems which were already in used either in mostly in the European countries. In 1957, we decided to switch over to 25 kV 50 hertz AC traction because by that time the AC traction was already introduced in Europe, and the experience said that the AC traction is far better than the DC traction. The European railway network, they were already moving their system from DC system to the AC system. The manufacturer who were providing us the spares for electric locomotive and for the ERD system, they were closing their shops. It was becoming difficult for Indian Railway to maintain the existing fleet of DC electric locomotive, and it was decided that there is no point increasing the fleet of a locomotive which is becoming obsolete all over the world. So we decided to move from DC traction system to AC traction system. There were different technologies which were in use in Europe. Some were using 25 kV, 25 hertz, other were using 25 kV, 50 hertz. We had the option to choose either one of them, and there were a few more which were already there at a lower frequency. Then there were two criteria. The first one is that the technology that we are going to import or that we are going to adopt should stay for a longer duration for us. And secondly, we should be able to procure the locomotive and we should be able to manufacture those spares in India. And third important criteria was that if we are requesting any of the European transport agency, we should get their technology either free of cost or we should get the technology at nominal cost. We approached different agencies. We decided to go for 50 kV, 50 hertz because that was considered to be the best system. And we approached French Railway, who readily agreed to provide their technology, and they also supported Indian manufacturers to establish their manufacturing units. And we in close liaison with the French Railway, we decided to adopt 25 kV 50 hertz system. And now, since we have accepted it once, we are going to remain with this technology for a long period to come. Because in case I want to change either the voltage or the frequency, it will require a huge amount of changes in electric locomotive as well as in the RD system. So whatever that we are doing now, we are only increasing the efficiency of the overall system. But the basic parameter, that is voltage and the frequency, that will remain same, maybe till the end of your career in the Indian Railway. The 1957, we had the first electrified section in Eastern Railway, that is Burdwan to Mughalsarai. That was part of Eastern Railway at that time. Then we had later on Tata Nagar Raurkela section. It was also completed. In 1976, Howrah Delhi route completed. In 1988, Mumbai Delhi routes were electrified. So these were the first few milestones which we achieved as far as the growth of AC traction is there in Indian Railway. In 1995, we adopted another system, which is an improved version of the 25 kV system. It is 2 into 25 kV system, and it is the only location where we have 2 into 25 kV system, despite knowing it well that this system is far superior than the existing system. When we incorporate the 2 into 25 kV system, the design of the substation is different. The ratings and the specifications for the equipments are different. But the OHE system that is available near the track or above the track, it remains same. The current carrying capacity of the copper conductor, the catenary and contact wire, it also increases. It means I can either increase the speed or I can haul the heavier load. We know there are many good advantages if we move from 2 into 25 kV system to from 25 kV system to 2 into 25 kV system. But unfortunately, we are still with one system. The one location where we have the system. Now, Indian Railway has already decided to increase the maximum speed to 110, 160 kmph. And it is felt that in case we want to increase the sectional speed to 160 kmph, it is high time that we move from 25 kV 50 hertz system to 2 into 25 kV system. So for the first time, after a gap of more than 20 years, we have decided to convert the existing Delhi Howrah route from 25 kV 50 hertz system to 2 into 25 kV AC system. So I'm trying to explain the time lag which takes place in Indian Railway on some of the important issues, and we sometimes lose a lot of market because of it. So it took more than 20 years to come to a decision that 2 into 25 kV systems should be used in Indian Railway. All new systems, including the dedicated freight corridor, they are going to use 2 into 25 kV system because there either we have the requirement of heavy haulage or we have the requirement of high speed. RDSO is working on the specifications. They will issue the specification by the end of this financial year. And then after that, those specifications will be used to convert the existing systems because the design of the transformer is getting changed. The design of the safety devices is also getting changed. And we may require extra land for erection of the new components. This is the organization structure that we have for the electric locomotive. At headquarter level, we have PCEE and his team. And in locochets, we have senior D locochet, senior DEE, traction rolling stock, DEE and PDEE. So this is the organization structure up to the division level, up to the zonal level. Here are certain advantages of electric traction. We can utilize electricity, which can be generated from variety of sources. It can be a fossil fuel generating system, or it can be renewable source of energy. There is no pollution at site, although there is a pollution when we generate electricity using coal. The coal-based thermal plants they produce harmful greenhouse gases, and in India, the 70% of the energy that we are generating, it is being generated using the coal-based power plants in our country. Now we have decided, because the people have become more environment conscious, we also have commitment at the international forums that we should try to reduce the use of coal-based power plants. And as a policy, it has been decided that no new coal-based power plants will be commissioned in India in future. We have faster acceleration and braking resulting in better running time. It is because of the design and the control mechanism which is available to the pilot that he can accelerate the train fast as a large amount of energy it can be pumped into the traction system, and braking is also smooth. Then we have reduced dependence on the petroleum product because we are not using high-speed diesel. There is a reduced noise level because the operation is smooth. We don't have DG sets. High speed of the train is possible because the overall capacity or overall horsepower or the tractive effort which is available in electric locomotive, it is more. And the regeneration is another concept that I will talk about in the later slides, which allows us to save energy, say up to 20 to 30% of energy is saved. In brief, I will only say that during the braking operation, the motors they start working as the generator, and rather than consuming the electricity, they start producing the electricity. And the produced electricity, since it is not required for the locomotive, it can be used another locomotive, electric locomotive, which is in the same feeding zone, or it can be returned back to the distribution company. We have a net metering arrangement or agreement with the distribution company, and we have to pay the bill for the net amount of energy that we have consumed in Indian Railway. So rather than wasting the energy in the form of friction energy or the heat energy when the brake binding takes place between the brake block and the wheel, we are converting that energy into usable energy, returning it back and saving on the electricity. We have a large number of locomotives in service, and in order to identify the locomotive easily by all the people over the entire railway, we assign a unique number to a locomotive so that the locomotive can be traced and it is easy to communicate about the locomotive. We have a 10-digit alphanumeric series which identify the locomotive uniquely by everybody in railways. The first letter is indicates the gauge for which the loco is designed. If it is W, it is a broad gauge. The second letter indicates the traction type. If it is A, it is AC traction. If it is D, it is diesel traction. If it is C, it is DC traction, or we have the dual traction or AC-DC traction. The third letter is the type of service for which the loco is designed. If it is primarily designed for the passenger service, it is P. If it is for goods loco, it is D. The fourth letter indicates the version or the type of technology that we have used to design the locomotive. And the fifth letter, it indicates the modification. Suppose I'm using the same technology, and within the same technology, if I'm carrying out a major change and a new version is not warranted, then I indicate it by the fifth letter. Now, if we see in the form of the operating system that we have in the computer, the fourth letter means we had Windows 8 and Windows 10. So that is the fourth letter corresponds to fourth letter in for the electric locomotive. If I have Windows 8.1, then I had Windows 8.2, then the operating system remained of the version 8, but there were major modifications. That is why Windows 8.1 and Windows 8.2 were released in the market. Similarly, the same principle we follow for the locomotive. If we keep the overall architecture and the control system and the traction system intact, and we still carry out major modification, then we assign a different number. For example, earlier we were using tau TAO kind of traction motors. Later on, the Hitachi developed a superior DC traction motor. So we only replace the tau type of traction motor with Hitachi traction motors. The rest of the logo remain as it is the way it is. So the overall design and the overall capacity of the locomotive did not change. So we did not introduce a new version of the locomotive, but we assigned a fifth number, and that logo, those logos were identified with a letter H. H means that these locomotives have Hitachi motors which are provided in the locomotive. For example, this is how a loco is nomenclated. WAP5 means broad gauge passenger service. WCAM2 means broad gauge dual mode loco. Mixed service version 2. WAG9 means broad gauge locomotive. It is designed for AC traction and for good services, and it is version 9. So this is how a loco is named, and either these 4 digits or the 5 digits, it is followed by another unit 5-digit number. And if we combine all these 4-5 numbers and the balance 5 digits, we can identify a loco uniquely. Or we started importing the locomotive from 1954 itself. The first 4 locos, they were imported from the outside because we did not have any manufacturing capacity with us. The CLW started production in 1961 when the first WCM5 locomotive was manufactured. We continuously improved the technology because when we started the production, we received the technology from both English Electric and Hitachi. We took the best features of both the technology and introduced a new type of locomotive, and we started with WCM5 locomotive. Anyway, we Indians are very good at jugaad technology, so we could improvise the existing technology, do some jugaad, and came out with a new version of locomotive. Then later on, when there was a requirement to have a locomotive which can work in both AC territory and DC territory, because Mumbai area and Kolkata area, they were DC territories. They were still having 1500 volt DC system, whereas the adjoining divisions, they started having electrification with 25 kV AC system. So in case I want to start a train in Mumbai and want to take it to Delhi, so I need a locomotive which can work in both DC territory as well as in AC territory. So we came out with another locomotive, which was known as AC/DC locomotive, and these were the 3 important landmark locomotives which we came out with. The production capacity of CLW was less than the pace at which the electrification was taking place. So CLW could not meet the expectation of the electrical department. So we roped in BHEL, which is the PSU of India, of Government of India, and BHEL, they developed the manufacturing unit, and they started manufacturing electric locomotives at Bhopal and at Jhansi units of BHEL. They are still manufacturing locomotive for us, and they are one of the largest supplier for the components, especially the traction motors are still being manufactured by BHEL, and bogies are also being manufactured. So BHEL is continuing with the railway division in their organization. Later on, we had a large number of locomotives which were introduced in Indian Railway. You can imagine the plight of the officers who are posted in the loco sheds and who are supposed to maintain so many types of locomotives in the loco sheds. Although all the locomotives are not based at all the loco sheds, but out of these 19, each loco shed will have at least 3 or 4 type of locomotives, and they have to keep their spares independently because the technologies are different, the requirements are different. And the staff should also know the designs for each and every locomotive. Therefore, the training becomes very important that we have to train our staff at the regular interval. We had different locomotives, and you can see that the emphasis was to improve the horsepower. As when we released a new locomotive, the one common feature which you can see in this table is that the newer locomotive had a better horsepower as compared to the previous locomotive. Like from WM1 to WM4, each locomotive, as we release a new version, was more powerful as compared to the previous locomotive. Similarly, in AP series, WAG series, till WAG9, these are the manufacturer or the technology which has been taken or under the transfer of technology we had with the original designer or the original manufacturer. These 4 locomotives which I have marked with the arrow, they are important because these are the 4 locomotives which are still working in the Indian Railway. The other locomotives, they have already been outdated or obsolete or on the verge of moving out of the system. I have missed one arrow which I should have marked to the W9H locomotive, which is also a powerful locomotive and recently introduced. So these are the 5 types of 5 different locomotives which are managing the entire operation requirement for both passengers and goods services. Similar to the loco, we also have the bogie nomenclature. We have different designs of bogies which are provided in a locomotive. If we have a BB kind of a bogie design, each bogie has 2 axles, and we have only one traction motor to drive both the axles. So in this locomotive, we will have 4 axles, and we will have only 2 traction motors to drive the locomotive. The another design is PO kind of the system where we have 4 axles, and each axle will have 1 traction motor for its use. And the current example is WAP5. There is no other locomotive which is using PO kind of an arrangement. The locos which were having PO kind of an arrangement, they have already been condemned and removed from the services. So WAP5 is the only locomotive which is using this kind of bogie. The most common bogie that we have on Indian Railway in electrical locomotive is CO kind of bogie, where we have 6 traction motors and 6 axles. Each traction motor drives the axle independently. It is possible for me to isolate one traction motor at a time. And even if one traction motor is isolated during run by the loco pilot, there is no loss of efficiency in the locomotive. There is no need to reduce the speed of the locomotive, and the journey can be performed. So if there is a need to isolate the traction motor, the loco pilot can easily isolate it using some of the rotary switch which are provided in the loco cab itself. Oh, sorry, I've missed some questions which were there in the chat box because chat box was not visible. Just a minute. There is a question from Akansh. Which letter represents horsepower of the loco? There is no letter which represents the horsepower of the locomotive. But if I know WAG9, then all the controllers, the traffic department, all the officers and the staff of the electrical department, they know what is the horsepower for that particular locomotive. It is not possible to have everything in the 5 alphanumeric series for locomotive. Is the digit represent version? Yes, the digit represent version. If it is 9, it is version 9 of the locomotive. So these are the two questions. So almost time that we should wind up. So I will quickly discuss one or two more topics before we call it a day. So this is the most common design that we have in Indian Railway. There are three locomotives which are using it: the WAG7, WAP7, and WAG9. They are all using COCO bogies. How the train moves, the electrical energy, when it is given to the traction motor, the electrical energy gets converted into the kinetic energy, and that energy is being provided at the wheel reams for moving the locomotive in forward or reverse direction. So that is the basic principle, or the conversion of electrical energy into mechanical energy. Why do we need the energy? We need the energy to overcome train resistance. There is a friction between rail and the wheel throughout the journey, and this friction is high when the train is stationary. So we have more train resistance at the start of the train. Then when we are moving at the high speed, we are cutting the air. So we have again wind resistance that we have to negotiate. Then we have to negotiate the gradients without reducing the speed. The curvatures are also there in the section, and we have to provide the acceleration to increase the speed or to make up the lost time. So there are different requirements for which we need the tractive effort, and we also need tractive efforts which can be manipulated or which can be changed as per the requirement by the loco pilot. So these are the basic reasons why we need train electric power to haul the locomotive, and these are different areas where the electrical energy gets consumed during the journey. What happens when the tractive effort fails to move the train forward? We are giving the tractive effort is being passed on to the wheel, and the function of the tractive effort to move the wheel in the forward direction. If the tractive effort is less than the overall requirement of the tractive effort, the loco will move forward. And suppose because of some reason, and the train does not move in the forward direction, then the wheel start rotating at the same location, and we call this concept is known as wheel slipping. That means rather than wheel moving in the forward direction, wheel is rotating at the same location. When the wheel rotates at the same location, it continuously rubs the portion of the rail which is in contact with the wheel, and the rail also gets damaged at that location itself. And sometimes the track becomes unserviceable, and we have to suspend the traffic on that particular track before the portion of the rail is replaced by the civil engineers. And if the damage to wheel is also more, then the damage to wheel is also more, and there is a flatness which has developed in the wheel, then the wheel is also requires a change. And since it cannot be changed in its position, we remove the locomotive and replace the another locomotive. So the pilot has to use all his technical knowledge to ensure that there is no wheel slippage at the start of the train. We have provided one sending arrangement to assist the pilot. We have 4 center box which are provided in the locomotive, and the 2 center box which are provided in the front of the locomotive. 2 center box are provided in the rear of the locomotive, which are filled with the dry sand of small size granules. In case the driver observes that the wheel has started slipping, he immediately pushes the sand under the wheel. He has a switch or a lever which is provided in the loco tab. He operates that switch, and the sand from the sand box, it starts falling just under the wheel, near the track. As a result, the friction gets reduced and the train can move forward. So senders are the center boxes. They come to rescue for the pilots in case there is any wheel slip. Now we will stop here. We will talk about the basic component of electric locomotive from the next session onward.